Welcome back. We'll be looking at how to derive the PQ formula. And this is similar to the completing of the square. And this time we'll be using P and Q instead of having a number there and there. So let's get to it. Here's our geometric figure, the same that we had before, except now the distance here is P divided by 2, and this distance is also P divided by 2. And then we'll be looking to fill in this gap right there momentarily. But so far, this is our equation for what we have in the yellow and the brown there. So let's take a look again now. I've algebraically manipulated this now so that the Q is on the other side, because just like when we complete the square, we only want to deal with these two, the square and the two rectangles that are yellow. So now we'll fill in the hole, and since we know the height of this length is P over 2, then we know this is as well. And just like this is P divided by 2, that is as well. So then we know that the little blue square here has an area of P divided by 2 squared. So let's add that in then. Now, as you know with algebra, when you add something to one side, you have to add it to the other. So now we have the two rectangles, the big square, and then the new blue square, and that's all on the left side, and that has to be equal to this here. Now it gets kind of simple. We're just going to simplify this and solve for x. So let's take that next step. Just like before, when you complete the square, which we just did, you're able to factor instantly this part right into this, which is on the left side, okay? That is the factor of everything on the left side, just like when we completed the square when we had numbers. And this, of course, we didn't do anything with. But the next step is simple. We just take the square root of both sides. And when that happens, we'll get rid of the parenthesis here and that. It'll just go away. And the other side will start to look familiar. Because what happens when you take the square root of the left side, because it's the square of something positive and physical, we're going to get two possible solutions. Like the square root of 4, you can say it's plus or minus 2. All right? So it's really no different than doing that. And now that we have this, you'll recognize this as the famous PQ formula as soon as we get down to x. Okay, we were almost there. The only thing we had to do was bring that to the other side, and that's why it's negative here, because it moved to the other side. And now we have the complete PQ formula derived from completing the square. Hope that helps. See you next time.